Okay. Yeah, so welcome again. So we started looking at control structures and we looked at the if constructs and the loops. We look at the for loops and the while loop. Then look at the list as one of the data structures in Python. Looked at how to create lists and manage lists, remove, add, sort, and all of that. And lastly, we looked at list comprehension. So this activity where you have a list, you should have something like I won't write the entire code for you because I can't remember that now. So you should have like timetable, okay, and that would be 2 times what? 2 times I, right? For for I in range. Okay, so I think yeah, something like this. So this will give you the first one. Okay. So this is list comprehension with prime, but that's not. So from here now you can now do your for. Let's say j in range. I don't know what that code is doing. So they want to do now 3 to 10. So we'll do 3 comma 11, right? And then okay. See whether I want to start with this because it's going to be very tricky. But basically, you just need to put in your. So this will first generate the. Let's sort this out first. Then we'll come back to this. So let's run this and let's see what we have. So is this correct?
Yeah.
The answer is correct, but
The
it's
answer is
not.
correct, but you should show
This is
two
not what.
times.
This is not what
Yes.
we want to do. We want to have this printed as well.
Yes.
So where you have your in your for loop, just bring in that logic. Yes, in that inside your for loop, just put it here. This place are highlighted. Okay, just bring in that logic here, and that should take care of that. Then after that, you now have um, your another loop, and so this will be I, this will be J, and this will be 2 to 11. This will be 1 to 1 to what?
until
1 to 15.
15. That'll be 16.
So this something like this is what you're going to have, and it will give you your answer. So you can see this is 2. This is 2 to 2 times 1 to 2 times 15. This 3 times 1. Okay, so you can see this nested loop. We're using list comprehension.
Okay. Sir, so you did 2 for loops together.
So these things sometimes can be very confusing, but let's look at it this way first. Okay, so you can see 2 times 1, 2 times 2 like that. Then when it gets to 15, it starts again from 3 times 1. So that's the flow. That's the flow basically. So today we can move on to our discussion. So we have already looked at lists and various list operations. So let's look at the next data structures, which will be tuples. So what are some of the characteristics of tuples?
Uses cut brackets and it is immutable. That means it cannot be changed. It is ordered and it is indexed for those particular sequence possible for our pattern.
Okay. So unlike when we did create list, we use the brackets. Okay. For tuples, we use what is called, this is actually what is called parentheses. So we use what is called parentheses. That is this in a tuple. So this creates a blank tuple for us. And so for instance, we want to have like person. Okay. So when person equals Alice, comma 35, comma engineer. So these are tuple. So you notice the difference so far is in terms of the curly braces, nothing new, aside from what we have in the list. And we print it out, we have our results. Okay. Then you can also use to store coordinates, like just a coordinate. How do you write that? And you just put in the x and y. The x is 23 and y is 89. So you can use that as well. and it gives us the coordinates for or the content of that. So that is just basic about lists. And like sorry, basic about tuples. Then like list as well. If we want to access the items, so for example, we can say person, okay, and then we use this will give us what? Alice, okay, because that's the first item in that person tuple. If you change this to 1, it should give us the age. If you change it to 2, give us the engineer. If you change it to 3, it should give us an error about the index out of range. And when you see index out of range in programming, it's him telling you that what you are referencing is not within the range of that particular object. Okay, and also remember when we did our mango, we unpack the first 3 into ABC, if you remember. Okay, so there's something like that also with with um, um, with tuple. So we can say name, comma age, comma job equal person, right? And what happens at the end? We'll have the values in each of these items. Okay, so I think I need to print it before it will not replace them. So let's just do that. Okay, so you can do that with a tuple as well. And then because we can't change, because tuples are immutable, so we'll not be looking at all those where we're updating and all of that. But we can do something which is create a new tuple by adding existing tuple. So we can just say new person is to have another tuple. Let's call this Rob plus person. I want to get the start, the end, and we can run. Okay, so we cannot change the person, okay, but we can take something from it and push it to create a new tuple. So we have a new person called robot. If we go back and we run person, we still have person unchanged. Okay, because it's immutable, we can't change it. Some of these programs run, we can't change it, but you can, change something by adding another person to it. Okay, so that's that about tuples. Like I said, we're not going to spend much time on it because it has a very limited application in terms of what we're going to be doing. So we want to go to the other interesting part, which is dictionary. After dictionary, after list, another data structure you want to know is a dictionary. Okay, now you see that the first data structure we use the bracket, right? We use the bracket, which is for list. Second data structure, which is tuple, we use parentheses. Now in dictionary we use what is called the curly brace, curly brace, or curly braces. Now, a dictionary is a collection of key value pairs. Key value pair means that you have the key and then the value. The key is more like saying that the the um, the attribute of that dictionary, and it has to be unique. Okay, so you can have multiple keys with the same name. It has to be unique. You can have the same value, but the name of the key or the key pairs, rather the keys in each pair must be unique. So you can't have um, in a key you have maybe score and then you have another score. You need to say score one, score two. Okay, you can't have score in a dictionary. Okay, so you can take note of that. What else? Then another thing is that the key pairs are separated. Key value pairs are separated with colon. Okay, colon, and each individual item with comma. Okay, like the other ones we have been doing. The um the list, the tuples, we use comma to separate each item. So the comma still applies. Okay, but since it's key value pairs, the key and the value is separated with a colon. Okay, so let's have a dictionary called students, and student will have a name, and the name is going to be John, and then we'll have comma. That is, we have captured one attribute of students. Okay, now I want to capture their level. Okay, to capture their level, and then put in the value, maybe 300 level. Then I want to capture their course. Okay, so with this now we have just defined a dictionary, and just like the other ones, you can also declare an empty dictionary as, okay, so empty dictionary, just assign it the blank curly braces. That declares a blank um, dictionary. So if I want to see this, I just run this. I should have my what is it called? I should have my list. Dictionary is very powerful because you can use it a lot for, if you have a list, you need to plot a graph. In some cases, you may need to convert to a dictionary to be able to represent the data appropriately. So they all have their various applications, and we'll continue to see that as we go along. Then, if we want to access each value in the list, we can just say student, and then we put in our bracket, and then the key that we need. So that gives me John. Okay, if I need the level, put in level. Okay, if I need the course, just put that in, and it gives me the course. Okay, so this is dictionary for you, defining it, assigning value, and then accessing the items in the dictionary. Then it also has the get method, which can be used to access the values within it. So let's have student dot get is put in course. Okay, so instead of saying student course, you can also say student dot get and you put in course. But you can see that dot get is a method, so we're using a parenthesis and not a bracket. Okay, we're using a parenthesis and not a bracket because that dot get is a method. Then we have also adding or updating your list. Pretty straightforward. Just reference the item student um, level. Okay, I'm using single quotes, but I always encourage us to use double quotes because if you go to other programming languages and you get used to single quotes, you might have issues. Student level, let's change the guy to 400 level, and let's do student level. Okay, so the level has changed from 300 to, or we can just run everything. Let's see. Okay, so you can see the name still remains Jones, the level 400, and all of that. Then I talked about getting the um, the using the dictionary to plot charts. So this is very useful. So for instance, if you need only the values, okay, that would be that you need to pass to your I think your y-axis, right? And then the keys will pass to your x-axis. Okay, so you have um, the dictionary has dot keys and dot values, which allows you to access these specific items. So if you say student dot keys, okay, it should give us our dictionary keys. So you can see student dot keys, name, level, and course. And if I say student dot values, okay, I have John, funny level, and um, computer science. And then you also have student dot items to get all the items in the dictionary. Okay, so you can see student dot items will have the name, which is John, the level. I think I should just use this so that we have a better output. Okay, so we have student dot items, we have the name, John, level 400 course, computer computer science. Any question? Okay, so let's look at another list and create operations. So we have an inventory of fruits and their quantity. Um, okay, so we have an item. So let's say somebody bought 10 apples. So we want to update our inventory for apple. So we can just say, let's print it first. Okay, so we can print all of that. So we want to update apples. So that will be inventory. That will be for apples. So we use our, minus equal to. When you say plus equal to, you know what it does. So we use minus equal to, it means that whatever it is should be removed. So that should give us a new value for our apple. And let's say for banana, we had um, we add more, like 50. And then for grapes, we sold 20. Okay, so that's how we can update our dictionary. So you can see it changes from 50 to 40, 70 to 120, 35 to 15 based on our construct. Okay. Um, any question, Joseph? I hope you are following. Okay, so we have the dictionary method, which we can use to copy a dictionary. So we can have um, backup of inventory to equal inventory dot copy. Okay, and what that does is it creates a copy of, so whatever is in an inventory, it just creates a copy of it. So maybe for instance we want to back this up before we run the code. We can use inventory to achieve that. So dot copy will create a copy of your code, of your dictionary. Then we also have option to remove items from the dictionary. Okay, so let's say we want to remove a particular item. So we want to use the pop. So we can say RV inventory dot pop. We have bananas. And we can say print RV print inventory. Okay. So we have the inventory now no longer has banana added to it, and we have the banana popped into the RV, which is something that we just created, and we ask it to back up the value. So we have that there. Then we have going through items in an inventory, in a dictionary. In our own case, we have our inventory already created. It has some items. So I'll just increase that again. So I have inventory. Okay. So I've returned what is in it from the backup. And I created a backup earlier. So we can do for item and quantity in inventory dot items. Remember our dot items, we'll get all the items. So for item quantity in inventory, in list we just do for item in list, but that's because there is one item per entry. But in the case of dictionary, there are two items in pairs, and to present that item, we can't just say inventory. We have to say inventory items, which will return every of the items for us. So we can now print each of the items. Print that will give us the items. So we have the apple 40, banana 180, grapes 50. So how do we get the total items that we have in the store? Given this dictionary, how do we get want to know the total items in the store? So we need to find a way to how we can sum. Okay. Any idea?
Since we are talking about, we can do for high in inventory dot values, since we are dealing with the values only.
Okay.
Mm, okay. Quantity is equal to this.
Sum of item is sum. We need to declare our sum. Sum is 0. Okay, so you see sum of item is 175. Okay. Okay. So we want to check in the, so this should return only apples and banana without without returning grapes. Okay, so you can see we have apples and banana. There is no grapes there because grape is 15, and we say that for items in items dot inventory dot items, if the quantity is greater than 20, so it should return. This is uh, what is it called? Comprehension, dictionary comprehension that we're implementing here. But we actually need to filter our list. Basically, we need to filter our list. What else can we do? I know it's not going to sum for us. Well, let's just try it. Let's try to use dictionary comprehension to sum. So we have okay. So we have what did I do? That's not what I was doing. No. Constant inventory dot values. Okay, so it's not going to allow that. Uh, so that's it's not going to work. Any question on dictionaries? It's pretty straightforward. Okay, it's pretty straightforward. Then we have sets. Okay, sets is also something that is also very interesting, and it has its use as well. It has to be unique. The set has to be unique. If you put in repeated value to remove those repeated values from the set. So let's look at set of even numbers. And then of course you want to declare an empty set. Empty set. So let's have an empty set. Declare as, so this is how we define a set. Okay, so you can see say type of empty is set. So saying that empty object is a set. What's happening? Okay, so now let's put in some values in our set. Even as a 2. Okay, let's use that. Okay, so let's print that. So we can see the even object. We gave it how many? About 8 items, right? But gave us how many? 5. Is that 5? Okay, give us
Yes,
5 items. Why? Simple reason, because it has to be unique. Okay, it has to be unique. That's just a simple reason why that is so. So that's one thing that um, you have in sets, and with set you can do things like union, intersection, option or operations. Okay, so let's have a universal set so that we can use that to play around. Let's call it universal. So a universal set has all the numbers, and we have our even numbers, which has been neatly cleaned for us. Then, like we have in list, where a list can take different data types, that also applies to a set. So we can have a set taking ID. Okay. Continue. So we have John Doe is 35. His height is 1.8. Okay. What else? That's all. Okay. You can have a set um, like this. Okay. So let's do a set operation. I think I should bring this back here so that we can see it better. Okay. Let's just have another one. Set A. Set A is let's use this. So we have two sets, set A and set B. Set A is 1, 2, 3, 4, 5. Set B is 4, 5, 6, 7, and 8. So let's get the union of the sets. So we just need to say set A union B. Okay. Okay, let's paint it out. We have an error there. What am I missing? On hashable sets. So let's use the union keyword then. Okay, but this should still work. Set A. Okay, I think it was the curly brace I added. Okay, so union of set A and B is 1, 2, 3, 4, 5, 6, 7, 8. Then let's get the intersect as where the meets. Intersect, that would be set A and set. Okay, so it says 4 and 5. If you look at the set very well, it's 4 and 5 that they have in common. Okay, then another set we have again, union, intersect, difference of two sets. Set A set A minus set B. Okay, so it gives us 1, 2, 3. 4, 5 is not there. Okay, because we are saying that looking at set A, you should remove what is in. Looking at set A, should
Remove what is in sub B from set A.
no, what is I'm messing it up.
Any element
But basically any element that
that is
is
in set B
B
and in set A,
as
we
in
should
A,
remove it from A.
you should remove it. Okay, so that's what we want to achieve with difference of. If you turn it the other way, we'll have a different answer.
Yes.
We'll have 6,
6,
7,
8.
and 8 instead of that. Set. Okay. And let's have a set of fruits. And let's carry out some methods and then we'll be done with sets. Set of fruits. It has created a list for me. It's fine. Just change that to sets. So we'll have our sets. So what can we do? We can add more with I say fruits dot add watermelon. And let's run that. So we have more fruits. So what did you notice with our set that is unique? And then let's remove apple. Let's remove apple. So just pop it out. Fruits dot discard, and then we put in what we want to remove. Apple. Let's print. Prints. Okay, so we have 1, 2, 3. Okay. So that removes the item from the set. What else? Yes.
I used remove here and it worked.
Yeah, works fine as well. So what else? How do we check if something exists in a set? So we just say, for instance, print sorry, I'll remove apple now. So let's start with apple. Apple in fruits. Print banana in fruits. Okay, so apple in fruit says false, banana in fruit says true. I've looked at the last, there is no apple here, so it's false. Here it says it's true. Okay, so it means that you want to play around this, you can say if banana in fruits, do whatever you want it to do. Okay. Banana in fruits. What do you want to do? Can print banana is available. Else, banana is not available. Okay. Any question? So our dictionary. What is the name of our dictionary again?
Fruits. Okay, dictionary. Inventory.
So we have apple, banana, and grape. So let's add. How do we add more items? So let's using this if. So this is more like a lab. It's tricky but it's simple. So if the I'm sure that if the set I mean okay, so if the set of fruits is not in the inventory dictionary, go ahead to add it to the dictionary.
Actually, this now.
So how do you do that? So what's the set? In mathematics, say given. So what have we been given? I've been given our set to be fruits, right? I've been given our dictionary to be inventory, right? Isn't it? So
Yes, sir.
these are what I've been given. So we have to check if the fruit is not in the dictionary.
So if there are fruits that are not in the inventory, we should add it. We can use follow.
So our result is going to be a dictionary, right?
Yes.
Hmm?
Yes, sir.
Not a fruit, not a
Not
set.
the sets.
Okay.
Since we have our fruits already, we can use a follow. Abi?
Oh yeah, now my head is stressed out. So what do we go about it? The idea is only in my head, but it's not coming out. Yes, obviously we're going to need a for loop. We're going to need if to check if the fruit is in the inventory.
So for I in fruits,
I'm just typing. I don't know for in fruits.
colon
Let's not say for in fruit, for fruits.
for fruits
In
and fruits
fruits.
colon. Let me cut it out. If fruits, yes, not in inventory.
Okay.
Yes, we can do inventory fruits equals to 0.
Okay. So What is that doing? What is every fruit equal to 0 doing?
So for every fruit, for every value fruit that is not in inventory, it will create a key of that fruit
Of that fruit
and then give it a value of 0.
of 0. So let's say you want it to default the value to, let's say, 60. What else?
Print it out of the year.
Let's use a for loop to print for. Okay, so we have apples, banana, grapes, watermelon, guava, mango. Okay, so it didn't add banana again because we already have it in the dictionary, so it didn't change. Likewise, grapes was not added. Okay, grapes was also not added because we have it in the dictionary. Okay, then apple is not in the um, apple is not in the set, but it's in the dictionary, so it didn't even bother to go there. So you can see how Python simplifies this thing. If it's Java or this you want to do this, you sweat in the sense that you might have to go break it. Okay, the implementation is not as easy as that's one thing you observe with Python is just shorter code. Okay, shorter code. The task can be it's not that Java cannot do this, but it's just that when you compare the code, this is shorter. Okay, not any other thing. This is not even part of our code. This is just what is doing the trick for us. So it checks for fruit in the fruit set. If the fruit is not in inventory, not, because we have said not. So not is, so if this is true, the not will change it to false. Okay, and because it's going to be true, or rather it's going to be false, change it to true, then this will now be able to run. And then this is just printing out the output. Okay, any question? See why I talking about this dictionary and everything, it's very tricky, but if you grab the concept behind it, you surprise where you be you be looking at. I think I should use a dictionary here. I think this thing should be done with a set. I think this thing should be done with this. For instance, you want to pull um, random questions from a database. You want the ID to be unique because you generate random question, query the database, or rather, let's look at this way. Generate some random IDs. You know that your database has 100 questions. You now ask RAND to generate 10 random numbers. You don't know whether the random number will be unique or not. You have no idea. So you can say generate 50, or generate 10, or generate 15, and then use set and assign that to a set, so it will remove whatever is whatever is beyond the number, and then you can now say check the length of the what is it called, the set, to see if it agrees. You can now use that to send a query to a database to pull the question based on the IDs that you have. In that way, the question is going to be unique. If you like, run refresh the page 100 times, you'll be having different questions that will be generated at each execution. Okay, so we'll go for a 5 minute break and we'll continue with move on to functions. Okay, and then we can now. Okay, so we have 30 minutes or so. Let's see what we can do within that time. Okay, so we want to look at functions in Python. What is the idea behind functions? To start with, functions are a way of minimizing repetition. So in your program, so if you have a program where you're going to use something more than once, functions are a way of reducing repetition in your programs. So if you have a way, if you have a set of codes that you're going to use more than once in your program, then it's advisable um, to put that in a function. Okay, like the times table now that you created, you can just define a function that takes in the left and the right and use it to multiply and return a value, and you just drop that line and it will be giving you. Okay, so that's one thing about function. Number one, functions are in terms of the concept, is designed so that you avoid repetition in your program. Then the behavior of functions are designed to be you define them, define. At the point of defining the function, you are telling it what the function will do. So in Python, for instance, you have the def. Whenever I say def, Python knows that you are defining a function. So for instance, if I say def and do what and say hello, okay, this is a function. This is a function. But this function is not going to do anything when I call it. But I've actually defined the function. But it's not going to do anything because I did not give it a body. So it's one thing to define your function, it's another thing to tell it what it should do. Okay? And that is where the body comes in. Okay? So if we say hello and say print hello world, and then at the bottom we now type say hello, what do you think will happen? It will print hello world. Okay, but I'm going to remove this so that you understand the concept. So I have my function. If I run this now, it just runs to confirm that there are no errors in my definition. Okay, but it doesn't do anything. So a function that has been defined is just there until it is called. Okay, and in Python, how do you call the function? You call it by the function name. Okay, so in my own case, say hello is the name of the function. So if I say hello, if I type say hello now, what happens? It prints whatever the function has been defined to do. So this is a basic function that you can have in Python. A function has the def keyword, it has a name, then it has your parentheses, then a colon, and then the body of the function, which is what it's going to do. If you like, you're going to do 100 things, list it under it. Okay, list it under it. Okay, so that's one. Then also, we have functions that take values. We have functions that return values. We have functions that takes values but do not return values. We have function that takes values and return values. So you can have a function implemented in these various ways. For instance, we can define another function that says greets. Okay, greets, and there's a convention, more like a method, okay, that you can choose to stick with. Okay, so for instance, if you are defining your function and is going to be in more than one word, and because of the rule, your function, your variable name cannot contain space, okay, or some special characters. Okay, so you want to make sure that you avoid that in your function. So for instance, I want to say greet uh, person, and I do something like this, and I put space. It's not going to work. So I either use a semicolon, which is fine, or I just collapse it and do something like this. Okay, the reason why we're doing like this is not that it's not going to work. This will still work, but this looks like it's lumped together. But with this, you're able to read each word. Okay, so whichever way, you can use a underscore, or you do it this way, works fine. But do not say you want to short a function name. You want to shorten the name and say gr person. Put the function name in full. Let it describe itself. Greet someone. Okay. Greet person by what? By name. Okay. Greet person by name. So let's get the name. Print. Okay. So say def greet person by name, and they will put in the name. They will now say print hello and then name. So that if I want to call the function, I will now do what? I will say greet person by name, and I will now put in the name. Okay. So this is another function, but this function takes values but does not return a value. Okay. It takes value but does not return a value. Okay. So you have functions like that. So if you run this again, we should have hello world and oh, sorry, I need to run this. You say it's not defined, so I need to run it so it exists in the memory. Okay, let's run this now. Okay, so we have this, so you can see it says hello John. Where did you get John from? From here. If I change it to Bob and I run, it changes to hello Bob. Changes to hello Bob. Okay, so we have looked at basic function. I looked at a function that takes value. Let's look at another function that takes value and returns a result. So for instance, we want to add two values together. So we have, say def add two numbers. Okay, add two numbers. So if you look at this, you can see that it's slightly different, right?
Yes, sir.
There is a return keyword. So when you have a function that is going to do something and then return the value, then you need to use the return keyword. Okay, you need to use the return keyword is needed at the point of where you want it to return a value. Okay, so for example, this could have been um, z is equal to what, x plus y, and I will now say return z. I no longer return x plus y. Okay, the same logic. You know that one is a shorter code, right? So let's define it now. Let's run it in memory. So we can call it by saying print add two numbers, and we give it two numbers. So what happens? We should get the number 30. So the function is going to add 10 plus 20, give it to print, and print is doing what? Is printing the number 30. Okay, but this is just an showing of, but the appropriate way when you have a function like this is you want to store the value. So for example, say sum is equals to add two numbers. Okay, but then we can now print our sum, right? We can now print our sum. Run it, we still have the same result. Okay, you still have the same result. And you should also understand this. If you are writing your code, don't be too secretive. Write your code in such a way that when you come and look at it later on, you understand what it's doing. Okay, Python indeed is allowed to write shorter code, but don't say you want your code to be as short as possible. You now cut out some details. Let it be as comprehensible as possible, so that even after 5 years, if you look at it, you can still remember, this is what this thing is doing. Okay, so that is very, very important. So we have seen functions and how to define it and how to call the function. Everything we are doing here is simply calling the function. And everything we are doing here is what? What are we doing here? What are we doing here? We are defining the function. And we have to what? We have to run it. Means that a function has to be defined before it can be called. Okay, before it can be called here. So after typing the function, we have to run it. Okay. Okay, so we have seen that in Python you can define your function and then you can call them. You can assign value to it. Unlike other programming languages, there is something that Python has. It allows you to return more than one value. Most programming languages can only return one value. It's even stated in the rule that the function can only return one value. But in Python, your function can return two values. Okay? So let's say we want to calculate, what do we calculate now? With sum and average. I don't want to combine. Something I want us to also learn. Or maybe let's start from there first. So let's have calculate sum. Okay? So if you give it some numbers, it can calculate the sum. Okay? So we want to put in single asterisk there. The single asterisk there is simply saying that this function I'm defining is not expecting one value. Though I'm using one variable, but expecting at least two values when it's called. Okay, unlike where I said add two numbers, x comma y. Once you put two numbers in comma, that separated by comma, that's all. But here it can go even as to 100. Okay. So sum is equal to 0. Let me see. Okay. I think this is what I want. So if I call the function, I can just say um, total is equal to calculate, and I give you some numbers. Okay. So what happens? It's going to give me my result. But let's run this first. Okay, so let's run this. That runs successfully. Okay, so it says if you add 1 to 10, you get 55. That's the total. Okay, then how? Okay, so let's use this example here. I remember then in before Python, to swap numbers, you need the third variable, right?
Yes.
But in Python, you don't need a third variable. Okay, you don't need a third variable to swap numbers. Just swap it. So if you want to swap a number, okay, if you need to return two. Given the number, you need to return two. So with Python, you actually define a function that will return two variables. Okay. So for example, we have swap numbers x comma y. All you do is just what? Assign y to x and x to y, and return x and y. Okay, but then we have to, if you want to do this will result to 3 lines. You need another third variable called z. You store x in z, then now x can now take in y. You now store what is in z in y. That's like 3 lines of code reduced to one. Okay. So let's do that. Let's say a comma b. No. Okay. I think this works. Okay. So this is my number a comma b, 10 and 20. Before the swap is 10, 20. By the time we say a comma b is equal to swap numbers a comma b, what happens? It changes to 20 comma 10. This is possible for two feature of Python, that a function can return two values, and secondly that you can assign more than one. You can assign you can assign values to multiple variables in Python. Okay. Then also we can also make this to return sum and average. Okay, so let's just copy this and let's call it calculate sum and what? And average. Okay, so okay, so we have our average, which will be equal to the sum, which has been calculated already, divided by the length of the numbers that was supplied. And then we can say return sum comma average. Okay. So to call this function, you can just call that here. Okay, so I need to store this in two variables, right? Right?
Yes, and
Because it's returning two
two
values.
values.
Sum is total and what else?
And averages.
Okay, let's run this. Let's run this. Okay, so you can see sum is 55, average is 5.5. Okay. Any question? Then we also have uh, the option to pass in a dictionary to our function, just like what we did earlier. We'll come back to that. So if you look at this great function, we can also add something. There's also an option to add what is called default. Default means that the function is defined to have a value. Okay, so that even if you don't give it a value, it still works. Another way for default is called optional. So if I don't want this title to always take in a value, okay, if I don't want maybe miss slash mr slash miss, so if I don't provide a value for title, the program will still run. Okay, the program will still run, and what happens? It will say greet person by, let's change this to greet by title. I want to enter something else here. So greet person by title, the name, title. So we can say hello and put in the title. Okay. So let's run that. So if I say greet person by title, and I put in Andrew, and I run this, what do I have? It says hello Mr. slash Miss Andrew. So when you have a variable where the person do not necessarily need to provide the argument. So more like optional. If you provide the fine, if you don't provide the fine, then you need to that is how you define that variable. You give it a default value at the point of defining it. Okay? And then if I want to give it a value, I'll add maybe doctor here. So if I run this now, I have hello Dr. Andrew. Okay? So you can see. So that's how you can define variables and give it initial values that it can hold. Okay? Then let's look at variable scope. Let's look at variable scope. When we talk about variable scope, we are talking about the visibility of a variable. Okay? How visible a variable is. If you look at the function that we have here, okay, do we have any variable here? No, we don't. But here we have a variable called what? Z. We have a variable here called sum. Another sum, avg, xy. Okay. So the variables within a function are called local variables. What does it mean? It means that they live and die, or they exist and cease to exist within that function. Once that function ends, that variable ends. Once you call the function and the function runs, the variable has ended. But a global variable is not the case. A global variable is accessible across various functions. So for instance, if we define a function called global, so I'll just say globe var, I'll call it 12. Okay, all the functions that we have here can access this variable. All these functions. Okay, all of them can access the variable. Because it's what? It's declared outside the function definition. But these functions that have been declared inside, like this sum, cannot be accessed. This sum cannot be accessed by this swap number. So what happens if I create a sum? Just like this sum and this sum, are they the same? They are not.
No.
This sum is independent of this sum. Everybody is on their own because they are within a function. If I come here now and type globe and I put var and I put 12, okay, it's still going to work. So it doesn't mean that you have to define the function at the top. What it just means is that it has to be outside any function definition. You can see that it's touching the edge. These ones they moved inside, indicating that they are under this function. Okay, so that's global and local variable scope. Variable scope is very important when it comes to functions. Okay, so sometimes you want to work with a function, but you want it that the function, whatever the function returns, it should still be accessible. Okay, so that means you may want to say, let me not define the function. For instance, why a function that increases, that is called increments, doesn't take any value. Okay, but it increases our count, okay, by 1. It increases our count by 1. It does not return anything. So whenever you run it, it increase count by 1. Now, this if you run this program from now to tomorrow, nothing is going to happen because there is no count outside the. Okay, let's do def increment. Oh, sorry. Um, I just want to call increment. Okay. Okay, I think I need to run it first. Okay. It says unbound local error. You know, this function here is not an initial assignment. Okay. It's saying that the function already exists. Add another number to it. That's why we're getting that. So let's remove that plus. I just want us to remove that error first. Okay, so you can see it has run, but of course nothing is going to happen. And we say we want to print count. Print count. Where is it going to see the count from? Okay, say name count is not defined. Okay, so that means this count is only within this increment. So now let's define our count somewhere here as 1. Okay, and then we can say count plus equals 1. Okay, and let's see what we are going to have whenever we run the function. Okay, so what do we have? What is it again? Cannot access local variable count. What am I missing here? Okay, let's just use the global keyword then. Okay. Let's define this here. Let's run that. Okay. So our count is not accessible. I think I have to modify that, but this is not what I want. But let's just work with this for now. So what this is doing is just arithmetic. It's just carrying out an arithmetic operation. But you see that this function does not have a return, right? But we're able to access the value count because we have declare count not a local variable within the increment function definition. We have declared it as a global variable. That means it can be accessed anywhere in the program. So immediately I run the function, I say print count, it's giving me 2. If I run it again, I shouldn't get the same number. Oh, I have initialized it here. Okay. Okay. So if I run it again, okay, so you can see it's going to be increasing, right? Because the variable is global. So as long as I run this function, it's going to be taking what is the value of count and increasing by 1. What is the value of count increased by 1? So if I run it again, what is the value of count? 10 to increase by 1. The local variable has now, the global variable has changed from 10 to 11. Okay, so you keep updating, updating, and updating. Okay, so that's that about variable scope. That's that about variable scope. Any question? So we can stop here if you don't have any question. So look at error handling and opening, dealing with files by tomorrow.